Here's an overview of what I'll be talking about. First will be why data management is so important and give a little historical background on GeoGraphix. Next, I will break down an overburdened GeoGraphix project and explain what is happening behind the scenes. I will be spending a good portion of the time on the first two topics because they feed into the rest. From there, we'll jump into the database and start looking at formation and zone data, which will lead us into PRIZM. After that, we'll take a gander at GeoAtlas and GVERSE geomodeling. Finally, I'll finish off with a brief glimpse into the IT side of things with regard to GeoGraphix. So let's get started. When it comes to cars and computers, speed and storing capacity are mutually exclusive. The more stuff you haul, the slower things will go. A former coworker often said users wanting their large projects to have better performance were like folks who thought dropping a Lamborghini engine into a loaded U-Haul would make the U-Haul run faster. GeoGraphix has done a great job in this balancing act, but it can only do so much. To see how GeoGraphix manages the data, it's a good idea to understand a little about its history. GeoGraphix started back in the 80s and 90s as an alternative for independent geologists and small oil companies who could not afford Landmark's OpenWorks or Schlumberger's GeoFrame systems. It was easy to set up, no need for expensive Unix systems, nor learning how to use Unix. It was self-contained. Everything resided in a folder, including the database to the project. Porting projects from one computer to another was a breeze, unlike bigger systems. As small companies began to be bought up, GeoGraphix came on the radar of mid-size and larger companies. Here was a software that was easy to use in data centers, was pretty intuitive, and came with a host of tools built in for mapping, building cross-sections, and doing petrophysics on the fly. Halliburton Landmark, who had no Windows-based geologic interpretation tool, bought it with the idea of marketing it to small and mid-sized companies, as well as trying to integrate Landmark OpenWorks database into GeoGraphix. Eventually, they licensed GeoGraphix to LMKR, GVERSE geoGraphix. Throughout all this, GeoGraphix structure remained basically the same. More functionality has been added to it over the years, and each module is being rewritten to take advantage of today's memory capabilities. However, the structure of GeoGraphix is still pretty simple compared to its competition. All files for a project still reside inside a folder, including the database. This can be both a blessing and a curse, especially if there are multiple people working in a project. Think about your department directory. It probably looks something like this. In 2010, during the height of the oil boom, all of these folks were still working with the company. However, it is now 2020, and there have been multiple layoffs and retirements over the last 5 years. Only 3 people are left in the department. Yet no one has cleaned out the directory, so all of that data is still being stored there. If you say, Heather, we can't get rid of them. There might be something we need. Let me let you in on a little secret. The chances of someone needing something generated by a former employee and having the ability to find it are about 5%. 95% of the time, those folders are ignored. If the data in those folders hasn't been accessed in the last 2 years, the chances of someone needing something in the folder drops to below 1%. Mainly because the folks who knew the employee who generated the data are also gone. The same situation applies to your GeoGraphix project. Looking at an example project that Fred Poland was kind enough to provide me to play with, we see 15 AOIs, all, except for a couple, have 100+ layers. Yet only 9 are actively used, and 3 of them belong to someone who is getting ready to retire. There are also almost 200 maps, but only 10 of those are currently being used. The rest are so old that only the retiring employee would remember the people who generated them. Why am I making such a big deal about this? It is because of the three workers in the background that do a lot of the heavy lifting with regards to performance. They run on both the project servers as well as on your workstations. Let's take them one by one. The network access service is what connects the projects residing on the server to your computer. If you don't see any projects listed under Network in Project Explorer, make sure this service is running on your workstation. The database service is what manages the data and all the changes made to it. Manages the database, pardon me, and all changes made to it. This service on the server is managing not only the changes you make to the database, but all changes made by everyone who is actively working in a project residing on the server. The larger the database and the more folks working in the projects, the harder the service must work. Last is the list service, equal in importance to the database service. This service lists everything in the directory and manages all changes made to anything in that directory. When you first launch GeoGraphix and click on an AOI, if there's a lot of stuff in the AOI, it may take a little time for everything to display. This is because the list service is gathering everything in the folder and loading the list into memory. Remember, an AOI is just a subfolder to the project folder. That is why when you click outside of the AOI and come back, it lists everything immediately. On top of this, the list service is managing all of the additions, deletions, and changes made to maps, layers, cross-sections, and so on. It is in constant communication with the list service on the server, making sure everything is kept in sync. Like with the database service, the more people working in projects on a server, the heavier the load the list service must carry. So let's take a look at the example project again. This project has almost 59,000 wells and is about 42 gigs in size, with 11 gigs being the database. I know your projects are probably much bigger in size, maybe double or even triple in size, but this will do. Now, I've had to mock up this project, so I had something to show you. In general, though, 15 AOIs is nothing. Most projects I've managed in my career ran to 30 plus AOIs, each with 100 or more layers and files. So taking the example project, let's say there are 100 layers and files in each of the AOIs. That's 1,500 folders and everything in those folders the list service has to deal with. Folders, you say? They're layers, just one file. Surprise! No, they're not. Each layer is actually a folder that contains all of the components that create the shapefile. For every layer in the project, there is a minimum of 5 files inside of each folder which create that layer, and the list service has to manage all of them. So let's do the math. 15 AOIs with 100 layers each equals 1,500 folders with a minimum of 5 files each equals 7,500 files. That's a bare minimum. Apply those same metrics back to your projects of 30 plus AOIs and you can see how quickly the problem gets away from you. But Heather, I don't want to delete something that might be needed later. Everyone struggles with this. It is the reason why your personal drives at home are probably filled with files you haven't opened since Bush was in office, the first one. But think about it. These maps haven't been used in over 10 years. 10 years! The chances that whoever created them is drinking a Mai Tai on a beach somewhere in their retirement, and no one currently working has ever met them. You're not going to trust the work of someone they've never heard of. Delete, delete, delete. If you are truly paranoid, something I freely admit to being at times, archive the data that you want to remove from the project and put the archive in a folder labeled to be deleted in X amount of time. I find 2 years pretty sufficient. Then delete the useless AOIs and all their contents with impunity. It's so freeing. And your data manager and systems admin will come and kiss your feet, or at least take you to lunch, I hope. And then we have our friend, the database, or as I like to call it, the holder of all that is good and bad in a project. We all know there are 2 types of data in the database, the raw data and the interpreted data. Raw data is the bedrock of the database because as long as it has been accurately inputted, something companies spend a lot of time and money making sure, it is the actual record of the well and will never change. Interpreted data is, well, interpreted, meaning it is based on someone's interpretation of the log and other data for a well. Let's delve into some of this interpreted data and see what happens over time. Here is a common problem. This is a mild example with only 3 sources for the same pick. I've seen upwards of 7, especially when you get IHS picks involved. In this example, though, we have 3 picks by 3 different sources, 2 of them less than a foot difference. There are a number of reasons this happens. The current geologist doesn't know or trust the older picks, or someone has copied someone else's picks under their own source initials, are a couple of reasons I can name off the top of my head. Multiply this situation across hundreds of wells and hundreds of formations, and you start to understand the impact it can have on a database. Let's pretend GLW is the source for Gabby, the current geologist. She has been with the company only 6 months, and there's no one in her department who remembers who BP or KG is. Because she doesn't have any knowledge of these former employees, she ignores all of their picks and makes her own. The problem here is that all of the work that BP and KG have done is now ignored. And Gabby is now having to repick formations which have been picked multiple times in the past. If someone had set up a business rule that would consolidate the picks of them former employees into department picks, then Gabby might have been willing to trust the picks and not have to spend countless hours repicking the wells. In this well, there is almost 100-foot difference between Gabby's pick and the other 2, but let's pretend that it was just in this well. Also, let's pretend that BP and KG picks were consolidated into one pick with the source of GEO for geology. Pardon me. For most wells, the KDRK Geo pick have been accurate, but this one was off, so she repicked it. When she leaves the department, her pick will become the Geo pick, and her source initials will be removed from the project. The benefit is not only a cleaner database, but an easier work environment for the geoscientists when they no longer have to wade through thousands of unnecessary picks. Here is another example of clutter in a database. Having a pick with no MD is a complete waste of space in a database. You can't map with it, so why is it there? It is easy to create a script and automate it to eliminate these useless picks to keep the database clean. Pardon me. Before we move on, I'll touch briefly on IHS pick data. This project doesn't have any, not counting the GDS picks, but many companies do import IHS picks. When you do so, you often end up with 5 to 6 picks for the same formation and, more often than not, the same depth. That is because IHS likes to drive data managers insane. Okay, not really. What IHS does is provide the pick from the log, the driller, the sample, and so on. You can condense these down so that there's only one IHS pick by using a script that runs after importing the IHS data. Doing this will eliminate thousands of picks from your database and also make it much easier for geoscientists when they are building their queries. It might seem like a small thing, but it can have quite an impact on your workflows. Let's move on to Zone Manager, an incredibly useful but highly abused module. Zone Manager's purpose is to hold data that can't be stored in Wellbase. It gives the users the flexibility to map any kind of attribute if they want, or store specialized data for wells. Because each, quote, zone, unquote, is basically a spreadsheet, just about anything can be stored. The problem becomes when no one bothers to clean things up periodically, and you end up with hundreds of zones and attributes cluttering up the project, making it difficult to find what you're looking for. One of the things that I wish LMKR would do would be would do is to add the ability to tie zone and attribute data to a source. Because it is wide open, folks are oftentimes reluctant to overwrite existing data that might have already been saved to a zone. So they end up duplicating the zones and or attributes in order to avoid this. This can be avoided by having a department manager make the call as to whether or not to overwrite the existing data. Also, the existing data can be exported out of the project and archived if folks are really nervous about overwriting the data. The thing to remember is that if the existing data was put in by someone who is no longer with the company, the chances are nil that anyone will use that data in the future. Another common problem is when zones and attributes are created but never used. This happens quite often, and there are scripts you can run to find them. This example project actually has 33 attributes that are not being used anywhere, so why have them? The same with zones. If there is no data associated with a zone, then delete the zone. It can always be recreated in the future if the need arises. Moving on, one of the things that has always made GeoGraphix such a powerful interpretation software is because of PRIZM, what is now called GVERSE Petrophysics. For years, most other competing interpretation applications did not have the ability to analyze curve data or could do only very basic analysis. PRIZM, though, is surprisingly robust, allowing users to build user-defined equations to run different scenarios, calculate gross and net pay, and so on. Things that generally could only be done with full-scale petrophysics software like interactive petrophysics or TechLog. It does all this while integrating with all of the other modules, making it a really efficient module. But that doesn't mean it doesn't have its quirks. Some of these quirks have been resolved simply by the module now being a 64-bit application, which means running curve data statistics on a large batch of wells using a complicated UDE should run faster and have less chance of crashing the module like it used to do in the past. This example above shows one of those things that I find annoying about PRIZM, the way it handles imports. The automatic merging of curves, on the other hand, is very handy. On one hand, is very handy. However, you can easily end up with multiple merges. Theoretically, PRIZM should handle these merges with no issues, and it does, most of the time. However, I have seen wells with 5 to 10 merges crash a CDS run. I clean up the merges so that there is only one, and it runs fine. Yes, it is a pain in the patookie to have to go back and clean out all of the miscellaneous merging and splicing. But if you do, PRIZM will run much cleaner, and you will save yourself a lot of headache in the long run. PRIZM makes it easy to write curve data statistics or reservoir pace summations back to Zone Manager so that the results can be mapped. By using custom UDE, the geos can run different scenarios and then map them. It is easy to make copies of a user-defined equation, tweak it slightly, then run your model. It is also easy to end up with multiple versions of the same UDE with only slight changes in each, leaving folks to wonder which is the best or correct model to use. As you can see, JWA has multiple dual water UDEs. Remember Gabby, our poor new Geo? She has no idea who JWA is, but someone told her to use his model. That's great. Which one? Some companies will develop a standard UDE to be used, which I think is a good idea. That doesn't mean you can't try out your own, but like with the PIC data, as users develop better models, the standard UDE is updated, so there isn't much confusion as to what to use. When a user leaves the department or the company, their UDE is removed from the project. We're going to switch gears now and talk about GeoAtlas. One of the things I hear the most often about GeoAtlas is how easy it is to learn to use. You just create some layers, toss them on a map, and voila. The reason it is so easy is because GeoAtlas uses ArcGIS's runtime engine. As I mentioned before, every layer is actually a shape file created using the runtime engine. One moment. Nothing like a little congestion to brighten your day. In this example map containing 78 layers demonstrates the most common workflow I've seen, and one I wish I could break geos of doing. Notice how the majority of eyeballs are closed. Folks take a map, put every conceivable layer on it that they can possibly want to use, and then open and close the eyeballs as they need. This way, they don't have to go into the layers window, find and select the layers they want, and then position the layer where they want it on the map. Saves a lot of steps, right? Well, here's the problem. When you first open a map, all of the layers contained on that map have to be loaded into memory. That's why when you first open a map, you'll see all the map draw every layer and then remove the ones where the eyeballs are closed. So of those 78 layers, if you're only using 5, 73 of them are using up memory because they have to be ready to display if you need them. Good, you say. You want them to display instantly. Then you head over to ISOMap to build a grid, and it is taking forever for your new layer to be created. What's going on? Well, you need to remember that GeoAtlas and ISOMap are both still 32-bit applications. That means they can only use up to the first 4 bits of gigabytes of memory on your workstation. You have just tied up a chunk of that memory with 73 layers of data that you are not using. The thing to remember is that there's going to be a trade-off when doing this type of workflow. The more layers on your map, whether or not they're displaying, the less memory ISOMap has to work with. Now, GeoAtlas and ISOMap do fairly well with 50-plus layer maps. But there's another reason to avoid this type of workflow. How many of you have seen this message before? I bet quite a few of you have at one time or another. Remember when I said GeoAtlas opens every layer on a map when a map is first opened? This is done to verify the layer still exists. See, the actual map file, denoted as a .gmp, only contains links to the layers, not the actual layers themselves. It also contains the coordinate reference system the map was built in, which I'll get to in a moment. When GeoAtlas cannot find a layer associated with a map, this box pops up, allowing you to either reassociate the layer to a new location or remove it from the map. Let's pretend our intrepid Geo Gabby has made a copy of an old base map for her own use. The base map originally contained 70 layers. When she goes to open it, she gets this message, not being able to find the layer in any of the AOIs. She removes it. She continues to remove layers she can't find until the map finally opens. Once it does, she discovers that the map now contains 10 layers. She could have just built a new map herself in less time. I can hear you now. See, Heather, this is the reason not to delete anything. My response is this. There will always be a trade-off. One quick word about coordinate reference systems, or CRSs, and GeoAtlas maps. When a GeoAtlas map is built for the first time, the coordinate reference system of the project is saved inside the map file. There is no way to change the CRS once the map has been built, even if the map is copied or moved to a project with a different CRS. For example, if you build a map in a project with a CRS of UTM Zone 13, and then move the map and all of its layers to a project with a CRS of UTM Zone 14, the map will still remain UTM Zone 13, even though it now resides in a project with a different CRS. The layers will stay UTM Zone 13 as long as they are being used in the transferred map. If, however, a transferred layer is then used in a new map in the new project, this is the message that pops up. If the old map is then opened, this message will pop up again when the layer is being opened. This transformation will continue happening until the old map is rebuilt in the new project. This is something that needs to be taken into consideration when moving maps and layers between projects. Let's make our way over to GVERSE geomodeling. It is amazing the things that you can do with it. Creating surfaces creating surfaces in 3D and adjusting them on the fly, using Smart Section to create your cross sections and watch your model automatically adjust to your formation picks are just a couple of the cool features you can do with this module. But first and foremost, before you begin, you have to set your model up correctly. This means creating a strat column specifically for your model. The strat column displayed here is from Fred Poland's class on setting up your geomodel. As you can see, he has created a very specific strat column, making sure that the formations are in the correct order stratigraphically. Very important. And he only has 20 formations. He isn't using the public strat column, which has over 800 formations in who knows what order. The reason it is such a big deal that the geomodel will be built using, The reason that is such a big deal is that the geomodel will be building your surfaces automatically using wells you select in your interpretation or on layers you might have already created in ISOMAP. Like the overall project, the more steps you put in your model, the more it has to work. The number one complaint I have heard about the geomodeling is that it is really slow. Yet when I go to look at someone's model, this is what I find. Basically, they have recreated their GeoAtlas map, all 50 plus layers of it, in the geomodel. On top of that, they've loaded thousands of wells into their interpretation so they can see them all, rather than depending on a well-based layer to display the wells and only adding those wells to their interpretation, which they really need. Consequently, whenever they try to update a surface or create a cross-section, everything moves so slow they throw up their hands and give up. You can't treat the map view as if it is GeoAtlas. That is not what it was designed for. It is just there to give you a 2D reference. It is not a map creation tool. It's all about doing the correct workflow for the module. As some final thoughts, I thought I'd give you all a glimpse into the IT side of things when it comes to GeoGraphix. From an IT perspective, GeoGraphix is actually a pretty stable application. Most of the time, when there are issues, it is related to the data in the project rather than a problem with the application itself. When there does appear to be some kind of systems issue, generally a reboot of the workstation, or on the rare occasions, the project server will fix it. There are several things, though, that GeoGraphix is particularly sensitive to, like network fluctuations. Because of our three friends, the GeoGraphix services rely so heavily on the network. I've always called GeoGraphix the canary in the coal mines because if an issue starts happening with the network, oftentimes GeoGraphix will be affected before it even registers on the network monitors IT uses. This is also why performance is often so much better after work or on the weekends, because the volume on the network is so much lighter. There are things, though, that IT does that can have a definite impact on GeoGraphix. The main one is security. Data and network security are incredibly important to a company. The problem is that security and performance are most times mutually exclusive. The tighter the security, the worse the performance on the network or a workstation. Companies struggle to find the right balance, but depending on upper management, some policies implemented can make a severe impact on the performance of any application, not just GeoGraphix. Some data loss prevention software is so intrusive, it is tagging every file that is touched. For an application like GeoGraphix or even Petrel, which is structured similar to GeoGraphix, the performance hit can be upwards of 30% or more. The main thing to remember is that IT does its best to mitigate as many of the performance issues as it can, but there will always be a certain amount that cannot be helped. Well, that wraps things up. Thank you for taking time out of your day to attend this presentation.